Hello, Amir. So today I'm going to talk about Lab 2 and the different solutions I used to complete this lab. So essentially we had a few different questions that we had to answer with first, and they're pretty basic, so I'll just go over it really quick. So the main difference between uninformed and informed searches are that in informed searches we do have additional information about the goal, as in more information than the ones that's already provided in the question. And examples of these type of searches include A-star search and greeting search, and as opposed to the type of searches in uninformed searches. So essentially, like depth first search and breadth first search do not have any additional information about the goal, so that's why they're classified as uninformed searches. Now, a heuristic can be defined as a function that provides an estimate as to how close a state is to a goal, as we discussed in the previous classes. In a search graph, various states exist, and this helps us determine how close a state is to a goal. Now, the basic idea behind heuristic search is to not ignore the goal when selecting the paths. So essentially, every step of the way, we've got to keep the goal in mind before selecting the path. And heuristic is admissible when the value is greater than zero, as in it has to be positive, but it should not exceed the true cost. So essentially, it just has to stay within that gap, and as long as it completes that, it is admissible. So I'm just going to go over the graph that was given to us, and this is where most of the explanation will take place. So the only thing we had over here was 2, as in the cost of arc AC. So essentially, I'll just start with the arc AB. So for B, essentially the cost would be 4 minus 3, so that's how I got 1. And essentially for D, it's 5 minus 3 is 2, but since this was already 1, it's essentially 2 minus 1, and that's how we calculate this. And what we need to keep an idea over here is that E is the goal node. So let's say now we're going to calculate for path CF. So already cost of AC was already given to us. So again, 5 minus 2 would give us 3. But since, again, we do have the cost of this arc, we should take that into account. So when we subtract that 3 minus 2, we would get 1. That's how I arrived at this. And essentially, yeah, so, oh yeah, and we also have to calculate the cost of arc CE. So essentially the same idea again. So here, 3 minus 0, because we've already arrived at the goal node. So that would be 3, but we do have to keep an account into the cost of arc AC, which is 2. So that would be 3 minus 2, and that's how I got 1. Now, is the heuristic H admissible in the previous graph? So yes, it is admissible. So essentially the same definition that we provided in the first question, the value of H is greater than 0, and it is not more than the actual cost. So example for node A, H of N is 3, and since the path cost E is 3, it is still not over the actual cost. So heuristic H is admissible in previous graph, and that holds for each of the node as well. So that's why we can conclude for sure that it is admissible. And next, I also did I represented it in AI space. So essentially, I created a graph and I included the goal node and the sharp node as well, and it included the edge cost and the heuristics. So essentially, before I do the actual simulation, what I did was in the first step, so node A is going to be in the frontier. And after expanding node A in the second step, we'll have 2 more nodes in the frontier. That's going to be B and C. Now, since this is an A-star search, it is going to keep the goal in mind. So it is in the next step after that, we would be going along the path of AC. So that means we'll have E and F in the frontier. And yeah, so basically the number of nodes I'll be expanding to reach the goal will be 3. And I'll just do a quick simulation just to do that. So this is the goal node, and I'm just going to run a quick simulation about this. So let's say I go switch into the solve tab, and this is the first step. I've already set the search algorithms to A star. And let's say I do the first step, and again, so in frontier was A, now it's B and C. So again, since this is going to be an A star search, it is going to expand along this path. And let's say I do it one more time. This is what we get. So it's 3 nodes expanded. And yeah, that is what I did in this. So I was able to verify that the prediction was correct. And yeah, so that's what an A-star search is about. It's more of it takes additional information about nodes, so that helps us arrive at the goal with a much more sensible approach. And yeah, thank you.